this lesson, we will cover Unit 7, Section 7.1, Developing Systems of Linear Equations. In this lesson, you will learn how to model a situation using a system of linear equations and how to relate a system of linear equations to the context of a problem. In grade 9, you modeled and solved situations and problems using linear equations, but that was only using one variable. However, in this unit, we are going to be introducing systems of equations where there will be two variables. And we're going to use these systems to model and describe mathematical situations. So first of all, what is a system of linear equations? Systems of linear equations is when two equations of linear functions have the same two variables. So you'll have two separate equations, for an example using a variable of x and y in the first equation, and a second equation with different coefficients that involve the same two variables. In order to solve a system, the number of unknowns must match the number of equations. To verify the solution, you could substitute an ordered pair, such as x and y, into both equations at the same time to make sure the solution satisfies both of those equations. And a system of linear equations is also referred to as a linear system. So the terminology for a system of linear equations could be also referred to as linear system, so get used to going back and forth with that terminology. So how can we model a situation using a linear system? So in our example here, George bought 22 movie tickets. Adult tickets cost $13 each, and children tickets cost $8 each. He spent a total of $246. Write a system of linear equations that could represent the situation. So as we go back through, we're trying to decipher what is given, and we have to set up two separate equations. So it's very similar to what we did back in grade 9. When you're given a situation, you have to write one equation. However, in this case, we need to look at writing two separate equations that describe the same situation. So as you can see what we have here, we have 13a plus 8c equals 246. Now how do we go about getting that? So that came about after looking at the sentence, adult tickets cost $13 each. So A represents an adult ticket. So we're going to say $13 per adult ticket. So it's 13A. Next we have 8C, and it's very similar to the adult ticket, but a child's ticket is going to be $8. So that's going to give us 8C. And it says that he spent a total of $246. So we're going to keep that 246 with the 13A and the 8C because it's all dealing with cost and money. Now that's only one equation. We need to figure out a separate equation that could also be used to model the situation. And since we're dealing with tickets, we're talking about an adult ticket and a child ticket. So that's A and C. So if we look at those separately now, how many tickets did George buy in total? And that was 22. So that will give us A plus C equals 22. And as you can see there in the box, there's three distinct steps that we need to follow. To determine how many of each ticket was purchased, write two equations to model a situation, similar to what is done on the left-hand side. First, identify the unknown quantities. So the unknown quantities here was the adult ticket and the child ticket. We didn't know how many of each ticket was bought in order to give us a cost of $246. We knew that there was 22 tickets bought in total, but we didn't know how many of each. And then your last step before you actually go and solve, you have to let a letter or a variable represent each thing that you were talking about, each quantity. So in this case, we let A represent the adult ticket and C represent the child's ticket. Next, when solving a linear system, a solution of a linear system is a pair of values of the variables A and C. So for that example we just discussed. that help to satisfy both equations. So oftentimes you may be given values for A and C and being asked if this is the correct answer or correct solution. So in order to verify that solution, you have to substitute the known values of A and C into the equations. And the left-hand side of the equation must equal the right-hand side. If that is the case, when you verify, then your solution will be correct. So let's say, still discussing and talking about the tickets, the movie tickets. Let's say that you're told that there are 14 adult tickets bought and there were 8 child tickets bought. Let's go back now and substitute that in for both equations to determine if that will be a correct solution. As you can see here, 14 and 8 were substituted in for the quantities that were unknown. And in both equations, those solutions do satisfy the equations. So for each equation, the left side is equal to the right side. Since A equals 14 and C equals 8, they satisfy the equations. Therefore, this is a solution of the linear system. And substitution, as we go along in this unit, to verify will become a very important part of solving a linear system. Now, in summary, you can be given a situation and any related problem. So there are always steps to follow. Once you get your problem, you're going to identify the variables. As can be seen by this problem, let X represent the number of boxes with 12 balls, and let Y represent the number of boxes with 24 balls. So, first step, identify the variables for your unknown quantities in order to model the situation using the linear system. And the last box there, model the situation with linear system. So you can use all different types of variables. You don't have to be stuck with just X and Y or A and C. The variables always correspond to the question being discussed.